Hello, and welcome to the video on the manager. So we just covered the handlers, and now we're going up again, one more step to the manager. As I said, we're going from the bottom up because everything above needs all the stuff below. So the handlers, to talk about handlers, we needed to understand the subsystem, and now to talk about the manager, we needed to understand what handlers are. So now that we do, we're going to be able to go and talk about the manager. So this right here should look familiar. This is the diagram of the handler. And the reason I wanted to bring this up was just to point out the substates. Right? Every handler only handles one subsystem and is always in one of the set number of substates that you've made. It doesn't have to be 4, it could be more than 4, it could be 10, could be 24, could be 3. But it's important to remember that one handler per subsystem. And as you can see, it can kind of end up being a lot. This is based on our 2025 robot, and believe me, we had a pretty simple robot this year. But when you break down into all the different subsystems, and each subsystem all has their own states, it starts to become a bit of an issue. Imagine during a match, you want to pick up an algae. Well, you're going to have to go through and individually select every single state. And you're probably going to forget about one. And you might misclick and select the wrong one. Or you might forget what one does, and forget what's the difference between aligning and aiming. It's a mess. Clearly, we are not done with our state machine. So, that's where the manager comes into play. This right here is the manager. It has a lot of similarities to a handler, but it also has some key differences. So you'll see it still takes in 2 inputs. It still has a set number of states, and it's only going to be in one state at a time. However, you'll see it controls a lot more than just one subsystem. So a manager is kind of like a handler of handlers. You see, the manager manages every single handler on the robot for every single subsystem, except the swerve drive, and you'll see why later. And it has a robot state instead of a substate, like we talked about before. So here we have the substates. But in the manager, we have the robot state. This is the thing that the whole robot is trying to do at that point. You'll notice the broken state is grayed out. See, the broken state is something that you want to have with the check subsystem method, where if the check fails, you probably want to say, okay, this subsystem shouldn't be used right now. So we're going to put in the broken state to make sure we don't break anything on the robot. However, here, there is no broken state, because if the whole robot is broken, well, you should just e-stop it, and there shouldn't be any code running at that point. So, just like the handler, we take in 2 inputs, but instead of being from the manager and sensors, it's from the aux controller and sensors. I've seen other teams call this the operator, right? The operator driver or the operator controller. We call it the auxiliary driver, and that's aux for short, just to clear that up. So the manager handles all those different button presses and readings from sensors, and then goes through and tells all the different handlers what to do based on the robot state. Just like a handler would tell the subsystem what to do based on the substate, the manager does it on the robot state. But what is a robot state really? And how does it do it for 4 different things at once? Well, this right here is a robot state. So this is the state we have to use our ground intake to pick algae up and score it. But this is just the pickup state, the intaking one. So as you can see here, it's just a collection of substates. So our pivot is in its intaking position, so it lowers our arm out of our robot so it's able to hit algae. The elevator is stored in its stored position. The rollers on our elevator are idle. They shouldn't be doing anything because they're used to dealgify the reef. And our algae intake, which is at the end of our pivoting arm, is intaking. So it's rolling the rollers at the end of an arm outside of our robot. It's a generic over bumper intake. So this is a robot state. So when the manager goes and it sees a button press from the aux controller, right? We press the X button. The manager is going to go and it's going to see, we're calling this set desired state method because it also implements this interface. The manager is going to set the desired state from being idle to being in the intaking state. So I'm going to draw it in here. And when it does that, because we're changing from one state to another, it has to handle that transition with the handle transition method in that interface. So what that's going to do is just do some checks, make sure everything's okay, before going and changing it to be in the intaking state. And we're no longer idle. So once the robot state is in intake, it's going to update everything, and it's going to update all of these guys when we handle that transition to the intake state. So every single handler is going to have the set desired state method called on it, and all of them are going to change their subsystem states and change the way they're controlling that subsystem. So when the state comes, all of these are managed by the one manager. So the pivot will start to move toward its intaking position, the elevator will go down and be stored if it was up, or just stay stored. Because remember, if set desired state is being set to something it's already in, it just stays there. It doesn't change anything. The rollers will be idle, it'll stop rolling, because again, the rollers are on the elevator, they're supposed to de-algify the reef, and our algae intake is going to start rolling to try and pick up the algae off the ground. So that's pretty much how the manager works. Let's keep going on this example here on picking up an algae. So once we've gone and picked up the algae, let's say, well, we don't have a sensor in there, we just eyeball it, but hopefully we do have a sensor in there next year, and other teams have sensors in their intakes. Right? If we have the time and we put in a sensor, when the sensor read, oh, there's an algae inside the intake, it would go and call that set desired state method we talked about so much, and it would change it from intaking to, let's say, hold. Right? Let's say you have something like, I don't know, claw, or you need to have constant grip on the algae. So then it goes into the hold state. And again, the hold state would change the way the manager is managing all these handlers. So every single handler would update their substate to change the way that they are controlling their subsystem. So every single subsystem is working in unison to work together to accomplish that robot state. So the robot states are the ones you actually press buttons on the controller to change. You don't need to worry about the subsystems. You don't need to worry about the handlers. All you gotta do is worry about the manager. That's really what you're doing when you're pressing buttons on the controller. So that's the manager. All it does is go through and manages all of the handlers to make it into one cohesive robot instead of a bunch of different guys split up into their own little substates, making it really hard and difficult. Manager's just is another layer of abstraction above a handler, in the same way that, a handler handles inputs for a subsystem, the manager does it for all the handlers on the robot. Makes it easier for us to go and create new behaviors, and makes it really consistent for the controls on the controller. And the final thing is it makes it really easy to create new behaviors for the robot. Because let's say we go through and we want to create some new behavior. Well, we can just mix and match the different states. We say, okay, this one's in that state now, and the elevator is in the L2 state, and the rollers in the scoring state, and the algae intake is in the idle state. If we just go and mix and match whatever states we want, we can go back and make a new robot state out of that. Notice we didn't have to change any code down here. We didn't have to touch our subsystems or our handlers. All we did was rearrange the states that make up a robot state, and we added a new one. So now we can have some new behavior that our robot does, and we don't even need to worry a thing about all that other code that we wrote before. Anyway, that's the manager. Next, we're going to talk about how do we add more stuff, what happens during the match, what happens every loop of the scheduler. So come back and watch that video.